Hello everyone, my name is Vaishnavi Pathade. I am from BEIT. Along with my friend Shraddha Idhate from BECom are going to demonstrate the book recommendation project today. Now, what is recommendation system? So first, recommendation system is just a program which attempts to predict the items that a user may be interested in. For example, we see Amazon. So in Amazon, we get all those recommendations of the products which we like or which we have bought in the past. So recommendation system basically helps us to increase the revenue of the company. Also, you can take the example of YouTube. So whatever the videos we have watched in the previous whatever the videos which we have watched previously, we get the recommendations based on that. Now there are two types of recommendation systems. So first is collaborative filtering recommendation system and content based filtering recommendation system. So first, in content based system, what we do is, if I have read a item and I have liked that item, so the recommendation system will recommend me those items based which are similar to the item which I have liked. So for example, it is like if I like the Shah Rukh Khan movies, then there is a high chance that I will watch all the Shah Rukh Khan movies. So they'll recommend me those items which are based on my interest and which I have. Whereas in collaborative filtering, the recommendation is based, it's not based according to the similarities between the items, but here you recommend the items or the things based on how much rating a user has given to that item. So, for example, here I have liked, like I have read this book, and some other person also has read the same book, and we both have liked the book. Now we both will become a similar user. So if the that book would be recommended to the other user also, to the similar user. So now in our project we are using collaborative filtering for book recommendation system. So first I'll share you the demo of our project. Here, this is the website, this is the front end part of our project. Done. So here in the home section there are top 50 books which are having highest ratings among that. So these are the top 50 books. Now the second is the recommendation engine. So here we'll give the names of the books, and according to that we'll get the recommendations of the next book which we have to read. So for example, if I write a Harry Potter book over here and I submit it, so I'll get the recommendations of all the Harry Potter books which I would like. So now I'll give you the link of the code into the description box, so you can check out there. If you go to that link, you will get to this GitHub page. Here, if you go to the code and download zip, so you'll get the code. And the data which I have used for building this recommendation system is, I have taken it from Kaggle. So this is the link which I'll provide in the description box. So when you go to the downloads, so you will get three files. So as we are using collaborative filtering over here, so we'll consider the users also and the ratings also. So these are the three files which you'll get. Now we'll go to the code. So this is the thing, this is the front end part. So this is the code. Now here, firstly, I have imported NumPy as NP and Pandas as PD. So these are the two Python libraries which I have imported. So here NumPy is used to perform the wide variety of mathematical operations on arrays, and Pandas is a library which is used for working with datasets. So it has the functions for analyzing, importing, and manipulating the data. So here pd.read CSV, as PD is used for data working with data sets. So we can read the CSV files which we have downloaded from Kaggle using pd.read CSV. All these files I have read. Then users.head gives the first 5 records of this users CSV file. Then the book CSV file you can see, and also the ratings CSV file. Then when we do the file dot shape. So we'll get the shape. So these are the number of rows into it, the number of records, and these are the number of columns. Then is null dot sum. This property is used for finding the null values into the dataset. So in books dataset, we just have only one null value for book author and two for publishers. And image URL large size, we have three null values. And in users, we don't have any null value. In the ratings also, we don't have any null value. So if we have any duplicated value, that also we have to check. So in all those three CSV files, we don't have any duplicated values. Now, as I've shown over here, in the home page, the top 50 books are shown. So how the top 50 books are calculated? So here is the code which we have done for that top 50 books. So here we'll display the top 50 books with the highest average ratings, but we will consider only those books which have a minimum of 250 ratings. So this is what we have decided. You can decide onto your on your own. So this is the criteria that will take those books which have the highest average rating, and will consider only those books which have a minimum of 250 ratings. So from the ratings CSV file, and we'll merge the ratings and the book CSV file, and we have the common column as ISBN. So we'll merge on that columns and we'll get a new data set, ratings with name. So from that, we'll group by the title, and then we'll get the book ratings. We'll count the ratings, how much the ratings are there for each number of books. So we have renamed the column for the as the num ratings, and we are displaying it. So in this lines, we have grouped the books and the ratings, and we have showed the number of ratings for each book. Now, as we have decided to get the highest average ratings, so we'll find the average rating for each book. So now again, we'll we'll calculate the mean of the ratings, book ratings for individual books. So this is the code for calculating the average rating or the mean rating for every book. So these are the ratings so for every book, and we have to take the average of it. Now we are merging it on the book title, so that we'll get the number of ratings also and the average ratings into the same data set. So and we'll call it as a popular DF. Now in the popular DF, as our criteria is, we'll consider only those books which has a rating of greater than 250. So we are sorting those out. So we'll consider only those books which have number of ratings greater than 2000, greater than 250, and we'll sort the values according, like we will show the highest number of average rating upwards. So on the average rating, we are sorting the data set. Ascending is equal to false means we'll sort it out in descending order. The highest the number of rating, the first will be the book. And head of 50, as we are going to show only 50 popular books into our website front page, so we'll get head of 50. So in popular DF, we have the popular top 50 books which we are going to show on our home page. Then we'll drop the duplicates if we have anything, and as we can see here, we have the medium size of URL, the book image, then we have the book name, the author name, the number of votes or the ratings, and the average rating shown over here. So we'll get those number of things which are displayed over here. We'll keep it in the popular DF and remove all the unnecessary columns. Now this was the code for this particular portion, this particular part. Now for the recommendation system, just as we are using the collaborative filtering, so we'll see that. Now in collaborative filtering method, we will not consider all the books and all the users, but we'll consider only those books or only those users who have done minimum of 200 ratings means those only those users so who read maximum number of books and who are experienced, and only those books which have got minimum of 50 ratings, and we'll decide this criteria, and based on this criteria we will consider for building our system. So based on the book rating, so if they have done, like, we'll count the number of ratings for every user. So user id is the unique id given for every user. So we'll calculate the number of ratings they have given per user. So if there are greater than 200 ratings, so we'll keep it in the active users data frame. Now based now we'll create an filtered rating df, and we'll say we'll keep it only those users which are active based on our criteria, we'll keep it into the filtered users, and others users will not take it into consideration. Now, same for book title, we'll calculate the number of book ratings, or we'll calculate the number of books which have got more than 50 ratings, and we'll keep those into the famous books df. And also now in final ratings also we'll keep only those books which have a minimum of 50 ratings. Now we'll draw a pivot table. In that, the columns would be the user IDs and the rows would be the book names, which are according to our criteria. So for that, for building a pivot table, index is equal to, so on book title, this is the row and these are the columns is user ID, and based on the book ratings, we'll draw a pivot table, and fill na is equal to 0. Here we are the non nan values will fill it with a 0 values. So this is the pivot table based on the books of all the books and the user IDs. Now, from sklearn matrix pairwise, we'll import the cosine similarity. So we'll find the similarity based on the pivot table. So for that, we'll use the sklearn library and we'll find the cosine similarity and we'll store it into the similarity scores. So this will be a similarity score. Similarity score is nothing but it is a similarity with one book with other books. Like for example, 706 rows. So we have 706 books into our those books are there into our criteria. So 706 books will have a similarity measure with all other 706 books, and these that will store it into the similarity score. So how much similar one book is with the other is stored into the similarity score. Now for the recommendation, this recommendation part, we'll write a code for recommending the book which is most similar. So now here in this function we'll give the book name, as we are going to recommend based on the book name. So we are going to give a book name over here. Now in this we are going to fetch the index where that particular book name is there into our 706 wala rows. So in this index we'll get the index of the that book name which we have passed. Then we'll find the similar items. So based on the similarity scores, we'll pass the index of the book which we want to search for the similarity, and we'll get the similar items based on the similarity score. So here reverse is equal to true means we'll get the books based on the like the higher the number of rating, those books would be considered, and 1 to 4 1 to 5. So this indexing means we'll get the top 4 books, all the books which will be there in the similar items. So we'll get those books and we'll drop the duplicates if we have anything, and we'll store the values into the data array of those similar items and we'll return the data. So for example, here we have run this code over here. So if we pass recommend function with 1984, this is the book name, then we'll get first four similar very matching book names which have the same content, or which has the same similarity, same concept than 1984. So Animal Farm is the first thing, then the Handmaid's Tale, Brave New World, and the Vampire. So these are the books which we have got recommended in our system. So we'll see over here if it works or not. So if we pass 1984 and submit, then we got these four books which are recommended based on the books which we have read or passed. So the same books came. Now this is just a backend part. So now we have to display it over the website, right? So for that we are going to import pickle. So this is what, so pickle is a library so which is used for exporting this data into some other project we can use it for. So pickle is a library which is used for serializing and deserializing the Python objects, and pickle.dump, this will store the objects data into a file. So the file which we have named is popular.pkl. Pkl is the extension of pickle and it is in the write mode. So when we run this command, we'll get a new library, a new file of popular.pkl which has all the all the content from the popular df file. Now again, if we have any duplicates or in the book title, so we'll drop those duplicates and we'll store it. Now similarly we will store all the three data frames, pt, books and similarity scores into the files using the dump function. The rest of the part will be explained by Shraddha.
Hello everyone, I'm Shraddha Idhate from BE and I will be explaining the GUI, that is the front end for book recommender system. So last we saw that the files which are needed for giving a recommendation, that is to recommend a book, we need the book title, author and the URL. So these are the basically the features which are going to be needed for recommendation function. So for recommendations we need the similar items, that is the similarity scores, the number of the top 50 popular books which we have dumped using the pickle function. So we have the similarity scores, the books which store the all the books, and pt which stores all the so pt has all the features like book title, user id and the book rating. So these pickle files are exported using the pickle function into the here python. Here we are loading these pickle files using pickle.load. And here we are using write binary. In Jupyter we used write binary. Here it is read binary. I'm sorry. So we'll start with the main function, that is the app.py. I'm writing the main function code here. So from I'm importing the important files, that is Flask, render template and request, also pickle and numpy. So I have loaded all the pickle files which we have which are needed. Then so I will start with the index. So in index so in this we have used html, css and a little bit of bootstrap. So using the render template, so I'm writing the html code in index.html and recommend.html, and these two html templates are displayed using the render template function. So this is render template function is a inbuilt Flask function which basically connects the templates of in the Flask. Okay, so here using the render template function I'm connecting index.html, and when I'm loading the index.html file, the book name, author, the image of the book, votes and rating should be displayed. So when I run it, I should be able to see, so I should be able to see the author's name, sorry, I'll start from the top. The book's image, the book's name, the author's name, number of votes, and the rating. Yeah, so here that's what we're displaying. I'll get to the index first. So here we have used basic HTML and CSS to design the front end for the index page. So using the title tag which shows book recommender system and some bootstrap and using inline css and css tags, we have designed the page. So using the nav tag, the nav bar where the background, here I've given the maroon color, using the class for nav bar, again a class for nav bar brand which shows my book recommender, it will display that. And using here the list, here these two on our page we can see home and recommend. These two are the functions which we are going to use, because home shows the top 50 books and you recommend, using the recommend button we are going to see what books are recommended for certain, like whatever input is given. Okay, so now using href we are connecting the home and recommend. Now the recommend has a different HTML here. Now using the href function we are connecting these pages to app. All right, so we'll create after creating another so in div tag another class named container is created, and here the positioning of the books and the labels is designed. So we need, like the books will be positioned in a row here, that is for I in range book length. So basically it means that the whatever the length of the books it is, MD3 column MD3, so basically 0 to 3, that is the 4 books in a row will be displayed. And this is the design, like the text will be white, it will show the book's name, author, votes and rating along with the image. So here image, it says that image I, so it is a list and I is the variable. So basically I stands for the number of book. So if the seventh book, I is equal to 7, so basically the seventh the book with the index 7 will display the seventh book's image and the seventh book's name, author, votes and rating. That's why for, so like how we do in loops, that's how we've done using lists in Python. Okay, and for in recommendation the code is pretty much similar to the main page. Here again the code is same for the title and nav bar, which shows my book recommender, and the same which is for home and recommend. So here what is different is that the in recommend books we have introduced the form tag. So using the form tag we are taking input. So from user input we are taking some text as input, and then we are using, then submitting it, and then the pre-processing will take place, and the and if the system will check if the book, the input that the user has given is in the data set or not. Yeah, so I'll show you this codes part. So in, so this is the design. So this is the user input. Here the user will give input, this is the submit button, and yeah, so because I didn't give any input it showed error. So yeah, so after giving input, and if I ask for recommend, it will give 4 books, it will recommend 4 books. Yeah, it says if data. So if for I in data, so what it means is data. So what does data contain? This data variable is a list. It is a list that contains the data of these items. So here we have created a list called item, and we have added book title, book author, and image URL in the item. We have extended these in as a in the list called item, and then we have appended these items which are an item the in data, which is another list. So basically what data contains are these three variables. So data has these three variables. Yeah, so we are going to check for I in data. So in the data, if it matches, if like I index 2, so if the variables match, and if all the data is matching, so for basically for if for book number 5, the same the book that book number 5's title, author, and image should be displayed. So if everything matches, then only this whole thing is printed in def, and that's it. Yeah, so the main code is then again in another route is created called recommend. Recommend UI will take the, this is for connecting the recommend HTML using the render template function. So in this recommend function, here the user input, this is the user input which we take in recommendation here. Here. So here we in form action we take the user input. Here input we take input. So it is for this in this function. So we are so this user input is taken using the request function. So here we are importing the request also. So this request is so that we can use the user input which is taken in the form. Yeah. So again here this is the same code which uses that similar items which we used in here also. Here this similar items code. So basically that line of code means that all the similar items, that is the books which are similar to the user input book, will be showed, and reverse is equal to 2 means that the book which has the highest similarity score, and reverse because if it's in ascending order it will be in the down in the lower parts. So that's why we're using this function. So yeah, this is the same that we use. These items are extended in the item list, and this item list is appended in the data list, and we are printing the data. That's all. Yeah. So the end result is, so to run a Flask file, you just simply have to run the file. So as I've already run the file, it will take it again. Yeah. Okay. So in home we have the top 50 books. So some of the images are not there because maybe the link for the image link provided in the dataset may have expired. So in the recommend, so I'll take the example given in the code 1984. So it is a George Orwell book, and 4 similar books to it are recommended. So Animal Farm, right? So if I check put an Animal Farm, it will give me similar books. So if we can put in different books also, like Second Nature, I'll just paste it. Yeah, so like books which are similar to Second Natures, like for Stephen King, will be displayed. In such a way, the recommender system works. So some of the I'll just say a few things. Some of the few things to look out for that most of the systems these days use the hybrid recommender system. So what hybrid recommender system has is what basically the popular based, collaborative filter based, and content recommendation system. So most of the mostly used hybrid recommender system is used. Yeah. Thank you.